In this video, we are going to introduce the idea of ions, ionic bonding, so how do the ions bond, and how to figure out binary ionic compound formulas. Elements, we have two types of elements, those that lose electrons easily. Typically, these are metals. And because they lose electrons, they form positively charged ions, which are known as cations. If you remember from previous videos, the charges in an atom are carried by the protons and by the electrons. In chemistry, we do not, at least in these chapters, we do not talk about the nucleus. So we do not change the nucleus. Chemistry actually happens with the electrons. Therefore, we do not change the number of protons. The number of protons stays the same. So the positive charges do not change, but what are changing are the negative charges. If we lose electrons, that means that we are losing negative charge. Therefore, the element becomes positive because we now have less negative charges than what we start with in a neutral atom. Elements, however, that gain electrons easily, these are nonmetals. Think about the division of the periodic table and where these are found. These form negatively charged ions, which are known as anions. We have negatively charged ions because we are now gaining electrons which carry negative charge. So technically we're gaining negative charge. The positive charge stays the same. So we either increase the negative charge by gaining electrons and forming anions, or we decrease the negative charge by losing electrons and we form cations. Once the ions are formed, we talked about this in chapter 1 as well, where we have positive charges that are attracted to negative charges, so opposites attract. Therefore, the cations, the positive ions, are going to be attracted to negative ions or anions. The electrostatic attraction that occurs between oppositely charged ions forms ionic bonding, and the compounds that are formed from the ions binding are called ionic compounds. So compounds formed from ions. This is a very important concept. So please remember, because it will be the basis of how we write these ionic formulas, ionic compound formulas. All ionic compounds are neutral, at least the ones that we're going to deal with. To be neutral, an ionic compound has to contain the same, so equal numbers of positive charges and negative charges. Now, that could be represented as multiple ions, so multiple cations or multiple anions, depending on how the charges are distributed. But all of my positive charge has to be equal to all of my negative charge so that they cancel each other and they give me an ionic compound that is neutral. So I have to count total charges, positive and negative, to make sure that they are equal. Let's talk about how we translate these now into chemical formulas. Chemical formula will identify both the elements that are involved in the compound, that make up the compound, and the ratio in which they combine to form that compound. So how many of each? 2 to 1, 1 to 1, 3 to 2, whatever the ratio might be. And that's what we have to calculate. With a basis of, so the principle behind it is that the ionic compound has to be neutral. Let's take a look at the compound that is formed from sodium, cation, which is an A+, and chlorine, anion, which is Cl minus. Obviously, these two are oppositely charged so that they will be attracted to each other. And they will form an ionic bond, forming an ionic compound. This compound will have equal numbers of sodium ions and chlorine ions. Why? Because their charges are opposite in sign and equal in magnitude. This is a +1, that's a -1. +1 and a -1 gives me a 0. So if I combine one sodium ion, and one chloride anion, because their charges, the magnitudes are the same, this is a +1, this is a -1, I can just combine them in a 1-to-1 ratio, and that will give me a neutral compound because a +1 and a -1 gives me 0. But what happens when we combine ions that are not of the same magnitude? So that their charges are opposite, but they are not of the same magnitude. Then we have to count more ions of the ones that has the lesser magnitude. To determine the ratio in an ionic compound, we find the smallest number of each ion that is necessary to cancel the other. Here's how the easiest way to do it. If I'm taking lithium ion and sulfide anion, okay, lithium is a +1. I don't write it, but it's implied that it's a 1. But sulfide is a 2-, so I have a 2, not a 1. Well, if you think about it, I need to get my positive charges to 2, because that's a +1. It needs to be a +2 to cancel the 2-. I cannot change the charge on the lithium. I cannot make this lithium +2 because lithium forms a specific ion, the +1 ion. It cannot form the +2. And therefore, I can't make this a +2. What I can do, however, is add another lithium +1. And lithium +1 and another lithium +1 gives me a total of +2 positive charge that will offset the 2- negative charge. The easiest way to think about this is to take the charge from the anion and bring it down as a subscript. So here it is, bring this down as a subscript by my cation. Remember that subscripts, when they're written right next to the element, that tells me how many elements I have. So how many of those ions of lithium I have? I have 2. And that's exactly what we said earlier. I need 2 of them to give me a +2 overall charge to offset that -2. So if I take the charge from my sulfur and bring it down as a subscript on my lithium, that will take care of how many lithiums I need. If I take the charge of the lithium, which is a +1, and I can bring that down as a subscript for my sulfur. Now we don't write the subscript of 1, it's just implied. So the formula then for the compound, the ionic compound that is formed from the lithium ion and the sulfide ion is Li2S, because I need 2 lithium ions for every 1 sulfur, because lithium is a +1 and sulfur is a 2-. Let's do this one. I have barium 2+ and chloride -1. Cross the charges. So take the 2+ from the barium and bring it down as a subscript by the chlorine. Here it is. I take the 2+ and I bring it down as a subscript by the anion. Then I take the -1 from the chloride and I bring that down to the barium as a subscript. Note once again that I don't write it because it is implied. I don't write the 1 as a subscript, even as a charge. So the formula of the ionic compound that is formed for the barium ion and chloride ion is BaCl2, because I need 2 chlorides, each with a -1 charge to give me a total of -2 to offset the +2 charge of the barium. What about this last couple here? I have aluminum 3+ and oxygen 2-. Once again, I'll take the charge from the aluminum and cross it over to the oxide and write it as a subscript. So I need 3 of those. I take the charge from the oxygen and I cross it over to the aluminum and write it as a subscript. Remember that charges are written as a superscript. How many of them you have is written as a subscript, right, by the element. So the charge from the oxygen comes down as a subscript by the aluminum, the opposite ion. So the formula becomes Al2O3. If you want to make sure that you've done it right, take how many ions you have and multiply it by the charge of each ion to get the total positive charge and the total negative charge. I have 2 aluminums, each of them has a 3+ charge, gives me a total positive charge of plus 6. I have 3 oxygens, each of the oxygens has a 2- charge. 2- times 3 gives me a -6 charge. And +6 and a -6 cancel each other, giving me a neutral compound, Al2O3. Here are 3 examples for you to try. Go to the periodic table and find lithium and chloride. Lithium is a +1, chlorine is a -1, magnesium is a +2, fluorine is a -1, magnesium is a +2, oxygen is a 2-. Now note that when you have, and I don't have an example here, but when you have ions that are made up of, or compounds that are made up of ions that have multiple charges, but they're both equal, but they're larger than 1, such as if I were to have here magnesium, for example, a +2 and a sulfide, a 2-. You can still bring them down here as subscripts, and it will be, instead of lithium here, I'd have magnesium, so Mg2S2. However, remember that when we talked about compound formulas, we have to use the simplest ratio, and 2 to 2 is not the simplest ratio. It's 1 to 1, so I would simplify that 1 to 1, or just combine. So if they have the same charge, if it's a +2 and a -2, just write the symbols of each element without any subscripts, just like we did for sodium chloride in the previous slide. I will give you a little bit of time to follow or to work on these 3 examples, and then we will continue on. Let's talk about binary ionic compounds. What does this mean? Well, we already talked about ionic compounds that are formed, are those compounds that are formed from ions. But what does binary mean? Binary means that they're made of 2 elements only. They're ionic compounds that are made of 2 ions, 2 elements alone. These can be divided into type 1 and type 2. The way we name them is very similar. The only difference is that for a type 2, which are formed by transition metals, we have to specify the charge in Roman numerals. But let's talk about these in a little bit more detail. Type 1 binary compounds, binary ionic compounds, are those compounds in which the cation is formed from a metal that only has one possible charge and no other. These are called type 1 compounds. Typically group 1, group 2, and just a few others that we will mention shortly here are type 1 compounds. They only form one charge, one positive charge. Those binary ionic compounds that fall under the type 2 compound, they are compounds that are formed typically from transition metals. Those are metals in the middle of the periodic table and are metals in which the cation, it can form multiple charges, so it's not always the same. For example, this is iron 3 oxide, and it's a binary compound that is a type 2 because iron in this case, which is my metal, is a transition metal, and it can form at least two different type of cations, +2 or +3. So I have to specify which it is. If I just wrote FeO for both of those, iron 2 and iron 3, or I just said, write me the formula for iron oxide, well, I have two different compounds that have two different formulas. So which one is it going to be? I have to specify what the charge on the iron is going to be, because then the formula is going to be based on that. And we cannot predict the charge of the transition metal just using the periodic table like we do with group 1 and group 2, etc. For these ones, we typically, to predict the charge given the formula, we look to the anion because the anions will always form the same charge. Oxygen in this case is a 2 minus. 2 minus, that gives me a 6 minus charge. That has to be offset by the positive charge, so my total positive charge has to be +6. And that +6 charge has to be distributed over 2 irons. So each of those irons has to have a +3. Or you can look at, what's my subscript by the oxygen? Well, that's a 3. Now I can backtrack and I take that up here as the charge on my metal, right? In the previous slide, we took the charge and brought it down as a subscript, but I can do the opposite too. I can take the charge from my anion and bring it up as, I can take the subscript on my anion and bring it up as the charge on my metal here, and that's iron 3. Here are some of the common transition metals, and you can see chromium, these are the most typical, but the chromium can form other ones as well, 4, 6, etc. But you can see that if it can form a +2 or a +3. Manganese, a +2, a +3, a +4. Iron can form a +2, a +3. Copper, a +2, cobalt, a +2 or a +3. Nickel, a +2 or a +3. Copper, a +1 or a +2. Here's mercury, a +2 or a +1. Note that when you write mercury +1, it's not just Hg +1, but it's written as Hg2, 2+. Okay, so it's written as this ion over here versus Hg2+. And then we have tin here, lead, etc. Note that there are 3 exceptions. So silver forms a +1 only. Cadmium and zinc form a +2. Those are exceptions. So even though they're in the transition metals, they only form ions with one charge. These are the same as group 1, which forms a +1 only, group 2, which forms a +2 only, and aluminum, which is over here, that forms a +3. Write the formula for the compound that would form from each of the following pairs. So try A, B, and C. Here's the first one. Now you can use the crossing of the charges, but then make sure that you simplify to the smallest whole number ratio, because that's how we write the compounds in chemistry. I will give you some time to try these.